Alright guys, welcome back. By popular demand, I'm bringing some videos back for you. Just kidding, no one really demanded it, but I do feel kind of popular, so we are going to continue with today's lesson. We are going to be still diving into triangles, and it's called constructing arguments, which is kind of cool because it's not so mathy, but it is all about kind of having an argument, but not in a bad way, a constructive argument. Having an argument where you have good, valid points and you can really solve a case by backing it up with facts and proof. So let's just take a quick look before we dive in to our problems at how you can construct a math argument to justify your statement, just to make sure it's true. So you can support your argument by making drawings, which you know Miss Kujawa is a really big fan of, or you can totally back up your argument by using a clear explanation and just backing it up with facts. So that's what we're going to be working on for today. You are going to be doing the evens with me, you're going to do the odds on your own, and good news for you, there's only 8 problems total, which means I do 4, you do 4, I might be doing 5, which means you do the math, but we will see how this goes. All right, here's our first argument. Samantha says a triangle can have 3 right angles. Okay, let's just think about this for a minute, okay? All right, Samantha, listen, we know when it comes to angles, we got 3 different kind of triangles. We got a right triangle, which looks something like this. We got an obtuse triangle, which looks something like that. And we have an acute triangle. It is so cute, and it looks something like that. So knowing our facts, which is how we can have good, valid, healthy arguments, is we have to know the definition. A right triangle has a right angle in it. An obtuse triangle has an obtuse angle. And an acute triangle has acute angles. And actually, sometimes it'll have more than one. So that right angle will indicate, let me use a different fun color, that there is 90 degrees. An obtuse is when it is greater than, let me use my greater than sign, greater than 90 degrees. And acute, you guessed it, is less than 90 degrees. So if we want to come back and talk to our friend Samantha, we're going to use our facts to back this up. It says list, oh wait, we're doing evens. Okay, but you're going to be doing this one, listing some properties of a triangle. Number 2 says, how can you draw to construct an argument? Well, I'm going to go back to what Samantha was saying, and I'm going to draw what she says. She says a triangle can have 3 right angles. So let's draw this out for a minute, which you know I love doing. All right, so I'm going to make this. That's going to be 1 right angle. And then, okay, it says 3 right angles. All right, Samantha, if that's how you want it, we're going to go down. That's going to be another right angle. And if I go across, I think if I hold it down, it makes a straight line. I don't know, Dylan was teaching me that. And then there's 3. Wait, what? Is that a triangle? As this guy would say. I don't know what he's saying, but it is not a triangle. So using this drawing, I can show you that when I do 3 right angles, it doesn't make a triangle. If I want to do a triangle that has a right angle, I can do a right angle triangle, but it's only going to have 1. So that's how I can use a drawing to kind of back up my case and to kind of show a visual. You're going to be answering the next one, is Samantha correct? And again, make sure you use some good math verbiage and use your facts to back it up. All right, moving right along here. Literally, we are almost done. Oh, you got my little SpongeBob sneak peek. I'm going to slide him back down. I'm going to turn my iPad this way, and I'm really going to be drawing all over this thing right here because it is great. And this is probably the main reason I didn't go up on the board, because just putting it on here will be awesome. So we're going to read. It says, Quentin took a picture of stained glass window that he saw at the library. He is using what he learned about triangles to classify the triangles in the window. Smart man Quentin. All right, let's continue down to number 4. It says, which triangles are right triangles? Construct a math argument to justify your answer. All right, so we're looking for the triangles that are right triangles. And I know that right triangles make right angles. And I'm going to kind of draw that onto the side here. All right, I need to look in every single shape that I see a triangle that makes a right angle. I'm going to put in R. The R stands for, you guessed it, Miss Kujawa is really cool. Just kidding, it doesn't really stand for that, but it does stand for right angle. So as I'm searching around, I'm looking for things that make those 90 degrees, and I am going to maybe color coordinate. So I think all the right triangles, I'll make them red. All right. I'm just searching. I'm searching. And I think that's all that I see. So I'm going to kind of zoom in, and with every little box, maybe I'll make my font a little thinner because Maddie G didn't give me her stylus today. I'm going to put a R in those boxes that make a right angle. And I'm going to keep going. Keep it going here. All right. I maybe shouldn't have covered up the number. Muy bien, muy bien. Okay, and if I were to kind of go back and it wanted me to ask which triangles have right angles, there was number 1. I'll zoom in again to help my handwriting. Number 1, number 4, number 5. Zoom back out. Turn my volume up. Number 9, number 10, number 12, number 15, and number 16. So those are all the ones that's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So those are all the triangles that make right triangles. Now, what can be my argument? Like, how can I justify that I know that those are right triangles? Well, I can say that 2 of the sides form right angles. They're 90 degrees, and that is me justifying. Am I able to type a text? I'm going to have a friend help me do that one day. So I'm going to say, in the triangles above, comma, 2 sides make up right angles. And then I definitely have to back it up that it makes 90 degrees. And having a picture to back it up is also a great way to construct my argument using a visual. So that's awesome. Alrighty. Now, lucky for you guys is when I did my little preview and I said, okay, I got to do all my even numbers. 8 asked to do exercises 4 through 7, which means I'm going to be doing some of the odds. But I kind of like it, and I like when you guys view my videos. So if it helps you, then awesome, awesome. So let's go to the next one. It says, which triangles could be, sorry about that. Which triangles could be right isosceles triangles? Construct a math argument to justify your triangle. All right, well, for this one, you have to know what right means, and you have to know what isosceles means. In the word isosceles, how many E's do you see? I see 2 E's. I'm going to make them like little eyeballs, which is kind of creepy. But isosceles means that you see 2 even sides. So to help my argument, I'm going to come over here and I'm going to draw an isosceles triangle. Alrighty. But now it says to do an isosceles right triangle. So actually, that would be an isosceles triangle, but do we see any right angles in any of the corners? No, we don't. So I'm actually going to erase that, and I'm going to think, how can I draw a triangle that has a right angle, but it has 2 equal sides? Oh, okay. Here's my right angle, and then I'm going to do my lines to indicate that, you know what? Let me use a different color. This side is going to be equal to this side. Boom. So we want to see where we can find any triangles that have right isosceles. Now, some of my triangles above might also be right isosceles, but our number 4 is correct. Those are still right triangles. But we want to see which triangles have a right angle but also have equal sides to it. So I am going to stick with the blue. I'm going to stick with the blue. So looking back at my right triangles, this one up here, number 1, those sides do not look even at all. It's not that one. Same with this corner one, because they look like they kind of mirror each other. That is not equal. Yagoramas, that's not equal. No. Ooh, this one looks pretty equal. So I think for that one I'm going to call it a RI for right but isosceles. A right isosceles. Let's take a look at these angles, and it's so much more helpful when they have the numbers. But this one also looks like an RI to me, a right isosceles. These also look pretty even. It's very hard to see, actually. Wish I had a ruler, if I had a ruler. Okay. And then this one also, because it mirrors the other side, so that one looks pretty even. And I think that's it. So I'm going to say the triangles that could be right isosceles is 4, 10, 12, and 16. And an argument to justify that is really just to define what is a right isosceles triangle. Well, we can say the triangles above, just like how we did the other one. The triangles above have right angles and 2 equal sides, because that is what helps us to identify what is an isosceles, 2 equal. Alrighty, y'all, moving right along here. Number 6. It says, which triangles are obtuse isosceles triangles? Construct a math argument to justify your answer. I'm going to grab a different color. And again, we just have to be knowledgeable about what is obtuse, what is isosceles. Well, again, I'm going to keep it creepy and do these little eyeballs in isosceles. Because when I see 2 equal, I got to see 2 e's. I'm going to move it to the side. I'm going to draw an obtuse isosceles triangle. So that is obtuse, but isosceles means 2 equal. So I need to do my best, which means I'm going to erase that. How do they make it a straight line? How do you guys do that? Don't you hold it? Oh, there we go. And then I'm going to hold it this way. All right. I don't know what I'm doing, but let's just say those are even. I'm going to connect it. And then these 2 are equal, but right in that middle, I'm going to make it rainbow. That means it's bigger than 90 degrees. So, coming down to here, oh, and I should have added that right here, 90 degrees in my right angles. Alrighty, which triangles are obtuse, but also isosceles? Alright, these 2 look even, and that's definitely an obtuse. That is bigger than 90 degrees. So we're going to call that an OI. OI, an obtuse isosceles. What also looks obtuse but is also isosceles? That is a fascisti obtuse, but these sides do not look equal. So it's just an O, it's just an obtuse one. And this one over here mirrors that. It's the same, that's just obtuse, but it's not an isosceles because those sides are not equal. That doesn't, that's not a right, that's smaller. Then that's cute. That's an acute one. I think that's it. So just for an isosceles obtuse, it's just number 11. And again, if we want to construct a good math argument to explain how did we know that, we are going to say that this triangle, and I'm going to draw it if that's okay, everybody. This triangle is greater, oh, sorry guys, than 90 degrees and has 2 equal sides. Boom. I was able to back that up saying that's how I knew it was obtuse and that's how I knew it was isosceles, because I'm smart and I could back it up, and I like having arguments when I have proof to back it up. sometimes if you have an argument and you don't have a good proof and evidence to back up your case, it's not that fun of an argument for you, more so for the other person. Alrighty, let's go down to number 7 again, you lucky, lucky ducks. It says, how should Quentin classify triangles 6, 7, and 8? Use the most precise name that you can. So let's go look at triangles. Let's use a different one, purple. 6, 7, and 8. Let's see what those look like. All right, 6, 7, and 8. How can we classify this? Well, first we want to look at the angles, and then we want to look at the sides. And I know we've really only talked about isosceles, but we can't forget that equilateral means that all 3 sides are equal, and that a scalene is that none of them are equal. They are not even on this scale. So let's take a look at the angles. Oh my goodness, they are so cute. I try to drag it out so you see what I did there, right? Alrighty. So we know that all the angles are acute, so it's definitely an acute triangle. And now let's take a look at the sides. Let's see. Here. Those are all pretty equal looking, don't you think? 1, 2, 3. That means these are pretty equal looking. And this also is equal looking. So if we want to classify this triangle, we could first say that the angles are definitely acute. And if we want to take a look at the sides, we can definitely say that the sides are equal. So Quentin is going to want to classify those triangles as acute equilateral triangles. Equilateral triangles. Beautiful, beautiful. Use the most precise name. That's pretty accurate. We talked about the angle and we talked about the sides. And again, maybe one day Maddie G will get me a stylus so that my handwriting can be much neater than it is now. All right, last problem. This is great. I cannot believe how fast this flew by. You guys are going to be triangle experts before you know it. Okay, let's move right along. It says, choose a triangle that was not listed in exercises 4 through 7. Use structure to classify it by both of its sides and its angles. So let's use another fun little color. Have we used blue yet? Yeah, we did. Let's use green. So we're going to do sides and angles that was not listed. So let's go back. And which ones did we not talk about? We did not talk about 3 or 14, really. And we did 2 and 15 on our own. So let's take a look at those. Those are both the same. So we want to see what kind of triangle this is, and we first want to look at our angles. Well, I like to make little rainbows or boxes if I have to. And all those angles are looking pretty cute, don't you think? That means it's an acute triangle. Perfect. So I'm going to come down here, but I don't want to forget it's for show an acute triangle. But now let's take a look at our sides, okay? All right, this is this big. Again, it would be so nice if we had a ruler. This one's this big. That looks like a pizza, and now I'm hungry. But anyway, these sides are both equal. But how many equal sides do we really see? I see isosceles. I see 2 equal sides. So triangles 3 and 14 are acute isosceles. Isosceles. Gotta spell it right. And those are the structures that we used. We said it's acute and isosceles. And now take a look at SpongeBob doing his little happy dance. He says, it is now your turn. Thank you guys so much. I will see you in Zoom. And as always, Ellen says, be kind to one another. Bye, guys.